Hey, I've been learning, a bit harder math, and I wanted to see if I could properly try and express how to do the Gaussian integral, which you can see right up here, this thing. I already have all the steps, planned out here, but firstly, let's start with just this. Of course, use substitution, integration of parts, stuff like that isn't really going to work. So we have to do something where we square the function and bring it into 3D terms. So I squared equals I times I, of course. So you take this arbitrary x and you multiply this whole thing by itself, but switch out the x for a y. So as you can see, we get that here. And this is the same as saying this. So yeah, let's just go ahead and put it as this. So we're going to be integrating this, and then eventually we'll integrate this with respect to y. Well, what is x squared plus y squared? It's r squared, which is radius squared. So negative r squared, of course, that radius squared comes from the circle formula there, which is the definition of a circle. So then we put in the definition polar coordinates for this, and we have this extra r here to represent how, like, spheres and circles, they widen and they get shorter, so we have that r there to account for that, which is gotten by, like, multiplying, like, the it's the determinant of, like, a matrix of polar coordinates, or like a Jacobian. It's my name, but, you know, the end. But anyways, we have this here, which is our polar version, with 0 to infinity and 0 to 2 pi. We can then use u substitution to get rid of that r squared and turn it into u terms. So, first of all, u equals r squared, right? So du equals 2r dx. Well, if you remember beforehand, we had r dr. So what's that? That's half of the original. So that's half of this. So we plug in that 1/2, and then put in the du and the e to the negative u. And then we have the deriving by, or not deriving, like the differentiate by the angles. So what is this? Well, the way you would solve this is by putting in e to the negative infinity. That's just going to be 0. 1 over e to the infinity is going to be 0. 0. Did I explain that wrong? Whatever. Let's go and ask Desmos what this is. Just 1. So we can check this by going like, yeah, right, because it's negative e to the negative u, and then if you plug in infinity, it's gonna be 0. If you plug in negative 0, I mean, it's gonna be negative 1. So minus negative 1 is gonna be plus 1 in the end, as you can see here. So the thing is essentially e to the negative infinity minus e to the negative 0, which is just 1. And then we bring that down, and then we have this very simple integral here. We have the integral of 1/2 times 1, 0 to 2 pi bounded, and we're differentiating by angle. Okay, we're back. This is the same as this, 2 pi over 2, and of course, since this is all I squared equals 2 pi, or just pi, because it's 2 pi over 2, so it's pi, then we know that I equals pi, the square root of pi, which is this. Of course, up here we have I equals this. They are identical. So I hope that could help you understand Gaussian integrals. I got interrupted part of the way through by my mother. So, yeah, I hope I could help you if you didn't understand how that all worked. It's something that requires a bit of like examining to wrap your head around. But thank you for watching, and goodbye.